Welcome back. During this video, we will continue discussing the topic how to utilize meta information. In the previous course, you got a detailed overview of how to do map side and reduce side joins, and how to work with data skew in Hadoop MapReduce. Now, get on board to take a look at the functionality Hive provides you to complete similar tasks. When you have several Hive tables to join, the default MapReduce implementation is a reduce side join. But tables meta information can help Hive framework to transform reduce side join into an optimized version of map side join, such as plain map side join, bucket join, and sort merge bucket join. If you have a small table according to Hive session definition, then Hive automatically tries to convert any found reduced side joins into optimized ones. Small is defined by Hive configuration parameters, such as row numbers and size in bytes. Having solved this problem with Hadoop MapReduce, you manually put a small table into a distributed cache. Hive framework is doing similar work. First, it downloads a small table into a client machine. Second, it builds a hash table in memory for join keys. And last, it uploads the generated hash table into a distributed cache. MapTask in this case loads the hash table into a memory from the local disk and uses it to match join keys while streaming a big table. No reduce tasks are involved in this process. Operating moderate-sized tables, you can't execute simple map side join, but there is a room for improvement. Tables bucketed and joined by the same set of columns can benefit from bucket map side join. Without loss of generality, let us consider join of two tables by one column. The simplest case if two tables have the same amount of buckets. Each mapper processing a file split from a big table retrieves only the corresponding bucket of a small table to complete the join task. If there is a different number of buckets in tables, then you should remember the following rule of thumb. Data in a bucket is defined by a hash of column or a set of columns, and then divided by the number of buckets in a table. So, having two buckets in one table and 4 buckets in another one, you can easily find out that the first bucket from a table 1 will correspond to buckets 1 and 3 in the second table. Having 2 buckets in a table 1 and 10 buckets in a table 2, the first bucket in the table 1 will correspond to odd buckets in the table 2. But having 3 buckets in table 1 and 5 buckets in table 2, you have to read all the data from other table to perform a join. That is why I recommend you to always use a power of 2 as a number of buckets in tables. Even if you have a different number of buckets in tables, you will still be able to benefit from bucket map side join. In comparison to other power-based systems, the power of 2 provides the best possible name node RAM utilization. If a bucket has grown to a size that you are no longer able to use in optimized versions of joins, then you can split buckets. If you use the power of 10, then you will increase name node RAM usage for this table by a factor of 10. Optimizations recognize no limits. Do you know how you can use information about data sorting? What is the biggest limitation of bucket map side join? You have to read buckets into memory. But is it really vital when you have data sorted by a join key? Exactly. You have already seen this example in the first course, when we were talking about algorithm called external sorting. External sorting is based on a merge sort algorithm, where you read continuous chunks of data only when necessary. Similarly, Sort Merge Bucket Join will read into memory only the items for a particular key, perform a join, output generated pairs, free up the memory, and move to the next key. At the time of shooting this video, it is by far the most efficient type of joins in Hive. To make it work automatically, you have to supply just a few flags. Now you know why it is so important to properly configure data layout. With the help of bucket configuration in Hive tables, you can execute bucket and sort merge bucket joins and explain how they work under the hood.